Here we're being asked to identify equivalent algebraic expressions. For A, probably the easiest way to go about this is just to go down our multiple choice here and see if it matches up. The other way we could approach this is look at our numbers here, our terms. We have 24x and a negative 18. We could do a prime factorization of 24, break it down, see if there's a common factor here with 18. If you were to do that, that might look something like this. When you have 24, if we break down 24, we know that 24 can be multiplied by 2 times 12. Well, 2 is a prime number, but 12 can be broken down further. 2 and 6. 2 is another prime number. So basically with this prime factorization, we're saying 24 is the same thing as 2 times 12, which is the same thing as 2 times 2 times 6. And then we can break down 6 even further if we wanted to into 2 times 2 times 2 times 3. And this is called prime factorization, where we're down to just prime numbers. So we see all the factors of 24. We could do the same thing with 18, where we could do 6 and 3. We could do 9 and 2, but 6 and 3 might be easier, and we can see immediately, that 6 and 6, they are common factors there. So we could actually factor out a 6 of both of these. And what I mean by factoring is that 24 is the same thing as, we could rewrite 24, an equivalent expression. 24 is 6 times 4. Well, an equivalent expression of 18 in terms of 6 is 6 times 3. These are equal. And so we could pull a 6 out of both of these numbers and be left with 4 and 3. Here we have 24x, so it would be 4x. So you can look up here and see that here where they've pulled out a 6, kind of not a good math term, but undistributed or factored out a 6. And this is what it looks like before the 6 is factored out. But if you didn't want to do prime factorization, you could just go through and work through this and actually do the distributing. Well, 6 times 4x, and then 6 times 3. 6 times 4x is 24x, and 6 times 3 is a positive 18. So that one doesn't check because, look, we have a positive 18 instead of a negative 18. So that one doesn't check. 6x, I think they're trying to trick you here, saying that maybe you thought that these were like terms, but they're not like terms because one has a variable and the other one doesn't, so we can't combine these. And then this next one here, we see 6 times 4x minus 6 times 3. If we use order of operations, our PEMDAS, we know that multiplication has to take place before subtraction. So 6 times 4x is 24x minus 6 times 3, which is 18. So this one checks out. And then finally 12x minus 9, which is just if we had divided each of the terms by 2, but it's not the same. So that one doesn't check out. So just the one on the top row. And then on the bottom row, before even looking at these, I see y plus y plus y. So as I go through and I say y plus y, will give me 2y. That'll leave me 2y plus y. And then if I add that third y, it will give me 3y. So as I look across, y plus 3, they added the constant there. That's not the same. 2y minus y is not quite what we're looking for, but 2y plus y, this is equivalent. If we were to add that third y, we'd get 3y, which they also have, so that checks out as well.